Good afternoon, everybody. In this problem, I will walk you through some of the questions that you may see in your midterm exam. So here is the first question. The coefficient of static friction between the two surfaces. So here the idea is that surface could be anything between the two glasses. It could be between the glass and the wood. The most important point is, do you understand what is the unit of coefficient of friction? So as an understanding, for your understanding, I will explain here. You know the coefficient of friction is given by mu times n. It could be static friction or it could be kinetic friction. It doesn't matter. What matters is this relation. And this mu is the coefficient of friction. And F is a frictional force and N is the normal force. So if you look at the unit of friction force is Newton. The unit of normal force is Newton. So this Newton and Newton cancels out. So that means mu has no unit. It is simply a number. Okay? It is simply a number. So if you have to choose one option out of these four options, you will want to look at the numbers which is a proper number, not with any units. So this would be the option because it does not have any units. All right, so let's move to the problem number 2. What this problem is asking you is, what is the equation for the weight of an object in terms of mass and gravity? So the weight is given by m times g. M is given, which is 2000 gram, and make sure that you always convert mass into kilogram. So the 2000 gram, if you convert into kilogram, it will be simply equal to 2 kilogram. So this one would be 2 times, and g value is 9.8 meter per second square. So the unit would be, so the number would be 19.6 Newton. All right. Okay. So now let's go to the problem number 3. So this problem, what is given here is the coefficient of kinetic friction, which is 0.2. And now you have to find out the distance a car will stop if it is moving at a speed of 20 kilometers per hour and the tires are still slipping, not rolling. So what does this mean? So let's first write down all the important information you have. So the given information is the coefficient of kinetic friction. Why kinetic friction? Because the car is in motion. Okay, so 0.2. And then you have to find out the distance. Okay, and the speed, the initial speed is given. The initial speed is 20 kilometer per hour, and remember you have to convert this into meter per second. If you don't do it, you won't get the final correct answer. Although your process might seem right, but you will never get to the correct answer. Always make sure that you have the proper units. So 20 kilometer, how do you convert kilometer? So the kilometer means, kilo means 1000. So if I multiply by 1000, it will take me to meter. Now I have hour. So how do I convert hour into seconds? So 1 hour is 60 minutes, and 1 minute is 60 seconds. That way I get to meter per second. Okay, so we have all the information, and now what does this mean? Assume tires are slipping and not rolling. This only means the tires have only translational motion, not the rotational motion. Okay, when the tires are slipping, it does not rotate, it simply slips. And that makes calculation easier. Okay, so now let's draw the free body diagram a little bit and understand it. So here is, let's say for example, the car. So the normal force would be this way. That's my normal force. The friction force would be along this way. That's the friction force. And the weight is this way, mg. And you know the formula for calculating the friction force. The friction force is given by mu times n, correct? That's the formula for the friction force. And if I look at this free body diagram, the n, the normal force, and mg are in the opposite direction, and there is no any motion in the vertical direction. So that means n must be equal to mg. So I can simply write down this to be mu equals to mg, because the normal force and mg are equal. And this is true when the motion is on a plane surface. If it is on an inclined plane, then n and mg will not be equal. So that's the friction force. And you know from the Newton's second law of motion, the F net, the total force, must be equal to the mass time acceleration. So that means this force must be equal to mass time acceleration. And I'm trying to make this video as short as possible, so I'm writing in source here. So what does this mean? This means this mass and mass cancels out, and I have A equals to mu times g. So I found my A value, acceleration. What is the value of mu? 0.2. G value, just to make calculation easier, I am assuming 10. So it will be 2 meter per second square. So I got my the friction for the acceleration. And now I know the initial speed, so I need to find out my distance. And one thing we know that when the car comes to a full stop, the final velocity is 0. So we are in fact given the final velocity. So let's write it down here. The final velocity is 0 meter per second. That is given. So now we can use another kinematic equation. Okay, so this equation, why did I choose this equation? Because I know my final speed, which is 0. I know my initial speed, which is this number here, 20 times 1000 divided by 60 times 60 square plus 2. What is my acceleration? Acceleration should be -2, and the distance, s is the distance, or you can call d, it doesn't matter. S and d are the same thing. So remember, s is also for the distance and d is also for the distance. It doesn't matter what symbol you use, you will get exactly the same answer. And now, why I have chosen the A to be negative? The reason is, you see the friction force is in the opposite direction. Okay, so everything that is moving forward will have a positive direction, and everything that is in the opposite direction will have the negative direction. So for example, the initial velocity, the velocity is in this direction, so that is positive, so this number is positive. Acceleration is in the opposite direction because this force is in the opposite direction, so I have negative. So now you have calculator, so you can plug in and solve for the distance, okay, s, and get your answer. So now let's move to the another problem. So we have given a 1500 kilogram car that accelerates from 20 meter per second to 2 meter per second to 20 meter per second in 5 seconds. So what is asking is the force on the car. So Here is how do I calculate. I won't write all the detailed information, but first you have to find out acceleration. And how do you find out acceleration? The acceleration is change in velocity, so final velocity minus initial velocity divided by time. So my final velocity is 20 meter. Initial velocity is 2 meter. And my time is 5 seconds. So 18 divided by 5. Okay, so that's my acceleration. And now, if I know my acceleration, so I can find out my force acting onto the car, which is the mass time acceleration. The unit of acceleration is meter per second squared. So you know the mass, so simply plug in 1500. Acceleration is 18 divided by 5. Do the math and you'll get your answer, and the unit will be Newton. Okay. So, and the one thing I will recommend to all of you, write down all your answers in the comment section below. Here is the problem number 6. So you have a stone that is dropped from the top of a building. The height of the building is given. So the height is given, which is 500 meter high. And now you have to find out how long does it take to reach to the ground, and what is the speed of the stone when it hits the ground. So let's say this is a 5 meter tall building, and you drop a stone here. When it comes to ground level here, what is the speed and how long does it take to reach to the ground, the time. So how do I find out? All you need to understand is the kinematic equation. So I'll write down the equation here. So one equation you can use is Vf, the final velocity, is equal to Vi plus Gt. Oh, okay, so first let's find out the time. So how do I find out the time? We are given the height. So we know this equation, h is equals to Vit plus half gt squared. That's the one equation we know. And the initial velocity, because when we drop a ball, the initial velocity is 0 meter per second. We're simply dropping it, we're not throwing it. Okay, so now you see the initial velocity is 0, so this term will be 0. So this term would be 0 because the Vi is 0. So I can solve the time simply by using the equation 2h over g. And I know all my information here. So 2, height is 500. G value is 10. And now you can solve it. Okay, that will give you the time. And now the next thing is the final speed when it reaches to the ground. So for that one I can use this equation. And again you can use the other equation too to solve it. For now I'm using this equation here. So here in this equation the initial velocity is 0. So now my final velocity would be Vf is simply equal to a square root of 2gh. So you know all the information here. 2, g value, let's say 10, height is 500. Just solve it now. And you'll get your number here. and the unit has to be meter per second, and here the time unit is second. So now let's move to another problem. So this problem, a car has is initial velocity given and an acceleration is given negative 0.1. So you have to find out the displacement after 10 seconds and after 50 seconds. So let's write down the given information. The initial speed is vi is given 2 meter per second. So let's if I have to draw, so this is how the car is moving. That is the initial speed. Acceleration is negative. What does this mean? That means it is in the backward direction. That is the direction of acceleration. Okay. So acceleration is given, which is negative 0.1 meter per second square. And now you have to find out the displacement or the distance after 10 seconds and after 50 seconds. So the displacement, the d, we have to find out after 10 seconds. The time is given 10 seconds, and also you have to find out after 50 seconds. Okay, these are the given information. So acceleration, velocity is given, time is given. So what equation I'm going to use? So you see, this equation I'm writing down here, plus half at square. Remember, the distance and the d are exactly the same thing here. Sometimes we use s, sometimes we use d. All right. So we're going to find out the distance. Initial speed is given 2. The time is given, which is, let's say, 10 seconds. Half a value is negative 0.1. Time is given, which is 10 squared, and you can solve it to find it. Okay, exactly the same way. Here I have used the time equals to 10 seconds, and you can use the time equals to 50 seconds to calculate the displacement. And write down your answers in the comment section below. Okay, so now let's move to another problem. And in fact, this problem and these problems are very much similar. The only difference would be the equation. You have to use the different equation, and it's very much same. So I'm not going to solve it. If you know the answer, write down in the comment section below. So I'm not going to solve this problem. So here in this problem, you have an airplane which moves 4 kilometers north. So I can draw my coordinate system. Let's call this one as a north. This is north, that's the south, this would be east, and that's the west. So plane has traveled 4 kilometers north. So let's call this is 4 kilometers north. Okay, and then it moves 3 kilometers south. I'll just change this problem a little bit. Instead of south, I'll simply make it east. 3 kilometers east. So now the plane moves 3 kilometers east here. The first of plane moves 4 kilometers north and 3 kilometers east. So 3 kilometers east would be this way. Okay, so that is my starting point, and that is my final destination. So how do I find out the distance and displacement? The distance is the total path you covered. So this one is 4 kilometers, and this one is 3 kilometers. So the total distance the distance is easy. The total distance would be simply 4 plus 3, that would be 7 kilometer. By definition, the distance is the total path you have traveled. You have traveled 4 kilometer this way and 3 kilometer this way. And the displacement is if you connect your starting position and the final position. So the starting and final position is this. That is the displacement here, the length. So the length of this one would give you the magnitude of the displacement. And how do I find out? If I look into this triangle, that's a right angle triangle. Okay, so the displacement would be it would be 4 square plus 3 square. If you do the math, that would give you 5 kilometer. So my displacement is 5 kilometer. Whenever it is asking you to find out the displacement, or in other words, let me see, if I simply give you 5 kilometer from here, you may not reach to this way. You can go 5 kilometer this way, 5 kilometer this way, 5 kilometer this way, this way. So in order to go from the starting point to your final destination, you also need to know the angle. So let's find out the angle here. So I can call this angle, let's call this angle is theta. Okay, so I'm calling this angle to be theta. So if I look at the triangle, so the tangent theta, if I have to look in this triangle, tangent theta would be 3 over 4. So I'm simply writing 3 over 4. So the way we find out is opposite versus this base here. So now the theta would be tangent inverse 3 over 4. Plug in your calculator and make sure that the angle is in degree, and you will get your answer. So now last problem here we have is a stone is thrown upward with an initial velocity of 20 meters per second, and it is asking you to what is the time to reach to the ground. So you can solve this problem in different ways. I will show you one approach and you can follow the rest. So here, let's say a stone, I have a stone and I throw it upward. So what will happen? It will go to a certain height. Stops here momentarily and then come back here. Okay, and it will come back here. Come back. So if I look at the speed of the initial speed, what is the initial speed given? The initial speed of the stone is 20 meter per second. That it is given. All right. And now, what is my final speed? Do I know my final speed? In fact, you know, if we simply ignore all the air resistance, the final speed will be negative 20 meter per second. Because you throwing the ball upward with a 20 meter per second. When the ball comes back, the direction of the ball would be opposite, so negative 20 meter per second. And that's the reason I have written down negative 20 meter per second. This negative tells you the direction that the ball is moving in the downward direction. Okay, so everything that we considered upward moving to be positive and everything downward is negative. And g value would also be negative 10 meter per second squared. Why negative? Because at any point the acceleration due to gravity is in downward direction. Okay, so how do I find out this the time here? The time we can find out by using this equation. Vf equals to Vi plus gt. If I use negative here, let me be clear. If I use negative here, then you always use the 10 meter per second. If I use plus, then you have to put the negative sign. The VF, what's the VF? Is negative 20. VI is 20. G value is negative 10. And that's the T. So the T would be, just solve it. You can solve it and get it. Okay. So this is it from this video. I have given you a complete review for the upcoming midterm exam. Go through this video, and if you have any questions, ask me. So this is it, and have a wonderful time. And do not forget to like, share, and subscribe the channel. Thank you very much.